So graphing on Tuesday? Graphing on Tuesday was fine, minus when you had like a fraction intercept, right? I think we could all agree yesterday was way easier. Substitution. The thing about substitution is it can take a while. Agreed? Especially if you make a mistake distributing and then you got to start all the way over. So I feel like it gives a lot of places for mistakes. And one of the frustrations yesterday is we had to make sure that we could pick an equation that we could get one of the variables by itself and try to avoid fractions. So what happens if we're given this one, and we're going to pretend that we weren't given this one? Yeah, you can scribble it out too. Say the other one was a terrible equation too, and I said to you, okay, your only option here is to take this equation and either get x or y by itself. What's going to happen? No matter what, we're going to get a fraction, right? Because if I have to get x by itself, that means I'm going to divide by 4, and 6 doesn't divide by 4 evenly. If I get y by itself, I have to divide by 6, and 4 doesn't divide by 6, nor does 32 divide by 6. And then we're back to that whole stupid F word of the fractions. Agreed? Okay, so here's number 3 for you today. You can solve by graphing. It's my very last option. Unless they tell me I have to, I never do it. You can solve by substitution, and substitution is nice when, like yesterday, they already had y equals something or x equals something. It's already by itself, and you can plug it in. So in this case, what if like one of our variables could just disappear? That'd be really nice, right? Dreams would come true. Okay. So could we take a variable, either x's or y's, that match number coefficients but have opposite signs? Crap, we need that equation. Sorry. Just rewrite it underneath. Just rewrite it underneath. I forgot that there's this part. So if we look at those two equations, do we have a variable that has the same digit coefficient but have opposite signs? 6y. Yeah, one has positive 6y and one has negative 6y. So stack it. Write it like a vertical addition problem. 4x plus 6y equals 32. And then, is it 3x? 3x minus 6y equals 3, correct? Okay. Now, Jackson pointed out the y's are both 6's, one's positive and one's negative. Okay, if I add these together, 6 plus a negative 6, my y's cancel, yes? What's 4x plus 3x? 7x. 32 plus 3, 35. Why is this a good thing? We divide by 7, and you're going to tell me x is 5. Now what do? Plug it in. Doesn't matter which one you plug it into. You want to plug it into 4x or 3x? So 4 times 5 plus 6y equals 32. 4 times 5 is 20 plus 6y equals 32. Then I subtract 20. 6y equals, then y equals, I think that just cut your time in half. Agreed? 5, 2. Now, technically, could I have shown you this yesterday? Would you have appreciated it as much yesterday? I don't think you would have. I don't think you would have. I got lots of things up my sleeve for you. Intentionally. You didn't, I set them up that way.
I got a fraction.
Not yesterday?
Yeah, I did, but I kept clicking quick retake until I didn't get a fraction.
Really? Okay, so let's look at my next one. Do I have a variable? Same digit, opposite signs. Which one? Okay, I'm going to take my right one and just write it underneath my left one, like this. Whoops. 4, I gotta get my other pen. 4x minus 5y equals 5. Everybody see what I did? I just wrote that second one underneath there. So if I add, this time my x's will cancel. 3 plus negative 5y. negative 2y, negative 3 plus 5, 2. Then I divide by negative 2, so y equals negative 1. Negative 4x or positive 4x? Positive. 4x minus 5 times negative 1. You can plug it into that one, that's fine. You'll get the same answer. Negative 5 times negative 1, positive 5. Then I minus 5. You still have a variable. You divide by 4. 0 divided by anything is 0. So this does have a solution. It would be 0, negative 1. You can't write no solution if you still have a variable. No solution, an infinite solution, only happens when your variable cancels. And you're like, why are we going over more examples, Miss Hoff? This is easy. What if the coefficients are the same? First thing I hate about this is they put x and y in different orders. So right away, I would go 2x plus 9y equals 22 because it drives me nuts. Thatcher, what's your idea? Okay, so if I put like a minus like this is what you're thinking? Okay, so then what would I do? Nobody write this down.
Like subtract all the stuff.
Okay, so what would I end up with?
4y or negative 4y, I don't know.
He's not really sure. Okay, I'm going to pause you right there. When you hesitate like that, I get a little nervous. But do you see what he's doing here? I don't disagree with what he's thinking. If I just took 2x minus 2x, they would cancel, right? So here's what happens. A lot of times we put that negative sign out there, that subtraction sign, but people forget that I'm subtracting 2x, I'm subtracting 9y, and I'm subtracting 22. So what I would suggest you do is to multiply your second equation by a negative 1. When you multiply by a negative 1, what does it really do? Just changes the sign, right? So instead of a positive 2x, I would have a negative 2x. Instead of a positive 9y, I would have negative 9y. Instead of a positive 22, I would have a negative 22. Okay, pause. Why did I distribute a negative 1? Okay, so what we wanted to do is we wanted to get our x's so they were opposite signs. Thatcher suggested we subtract, which would work, but a lot of times people forget that you're actually subtracting each of them. So I said just multiply by a negative 1. It's like distributing that subtraction sign. Yep. As long as you do it to everything, it's totally legal. The benefit of that is these are now opposites. They cross out. 5, and we're really adding these, plus a negative 9y is negative 4y. 6 plus a negative 22, negative 16, yes. Then I would divide by negative 4, y equals positive 4. Let's plug it into the original one. 2x plus 9 times 4 equals 22. 9 times 4, 36. Subtract 36, we get negative 14. Divide by 2, x is negative 7. Should be the same.
It's 2x plus
2x plus 20 equals 6. Yep.
minus 20.
Yeah, subtraction's hard, man. I feel you. But a good point proven here, right? Does it matter which one you plug it back into? No, you'll get the same thing. Okay? So if we look at the bottom one, what are we going to have to do here? Okay, so you have an 8x and an 8x, but if I add them, they're not going to cancel, right? So let's take this right-hand one times a negative 1. What do I get? Negative 8x, not minus a negative, minus 7y equals negative 7. Minus a negative is actually addition. You guys finish this out. See what you get.
Yeah, probably.
You got a fraction?
Yeah.
Negative 4y equals 4?
It's 14 divided by 8.
Negative 1. 8x plus 7 times negative 1 equals 7. 8x minus 7 equals 7. Plus 7. 14 over 8, divide by 8, 7 over 4?
Yeah.
We should talk to whoever made this worksheet. They should.
Hoosier or was it you?
Let's blame Mrs. Hoosier. It's absolutely.
You could go in her room.
Do we need to?
Yes.
Maybe let's not interrupt her teaching. Maybe when we get done, we will absolutely go in.
And just say you
And she wrote this in the wrong way too.
You hooligan.
That was intentional.
We don't let her talk.
I didn't do such a thing. I know, intentionally. Because sometimes they're going to be written that so that you have to rewrite them to match them up. Cheryl and Jackie work at an ice cream shop. Cheryl earns $8.50 an hour and Jackie earns $7.50 an hour. During a typical week, Cheryl and Jackie earn $299.50 together. One week, Jackie doubles her work hours and the girls earn they earn $412. How many hours does each girl work during a typical week? I'm going to tell you, I hate this problem, so we're going to skip it.
Yeah.
Yeah, we did.
The sum of two numbers is 28, and their difference is 4. I can add them if you want.
Oh my gosh.
All right, okay. The sum of two numbers is 28, and their difference is 4. What are the numbers? Do not guess and check.
I do that way too much.
Okay? There are two things you don't know in this problem. What are they?
The number.
The two numbers, okay? So x equals a number, and y is another number. Ms. Hoff told us yesterday that when we have two variables, we have to write two equations that both contain both variables, and we don't use the same numbers. What you got, Morgan?
X minus y is 4.
She says x minus y is 4. Thoughts? What word allowed her to write that? The difference is 4. Difference means subtraction. I like it.
Well, what about the sum? That's what.
Okay, so what would that look like? X plus y equals 28. Is she right?
Well, yeah, and then x plus y, if there's the difference between the two numbers.
Okay, don't try to guess it. Don't try to guess it. This is exactly what you want to write. Stop. 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 I just said, I don't want you to guess it. This does nothing for you guys to sit there and guess it, because we're going to get to a point where 2 days next week is only story problems. So this is my small introduction day by day to this. Okay? Now, what's a nice thing about this problem? The y's are going to cancel. If I add these, be careful. What do I get? 2x equals 32. So many people just say x equals 32. Don't forget it's 1x plus 1x. So I divide by 2, x equals 16. So 16 plus y, because I hate negative signs, equal 28. Subtract 16, y equals 12. So my numbers are 16 and 12. I know you can do it, but if you write the answer down on that, I will give you 0 points. The point of this is not to guess and check, because I'll just, I don't have them loaded on here. The insight next week is going to say like 2 times the first minus the 3 times the negative 7th of the last one gives you 22. And if you can't write an equation with it, it's useless. So don't guess and check. It does you no good. Next week, I'm going to tell you the Gonzalez family lets their sprinklers run for 12 hours and uses 32 liters of water, while the another family lets it run for this many hours and uses this, and I want to know the rate of both. Can you guess and check that?
No.
So don't guess and check. Got it? Online. Go to work.